Wait, the 1/2 is just like literally just the 1/2.
Oh, this guy, like that. Yeah? Okay. All right, so I'm going to do slope first. So y2 minus y1 over x2 minus x1. Change the denominator here. So this would be 9/4 minus 6/4 over, change the denominator here, 1/2 minus 4/2. All right, so then I get 9 minus 6. This becomes 3/4 over. This would be negative 3/2, and then keep change flip. All right, so where am I at? So the 2's crossed, the 3's canceled, and I get negative 1/2. That's the slope, okay? So now you can pick either point. Like, obviously, I would avoid as much fractions as you possibly can, so I would have picked the first one. Y minus y1 equals negative 1/2 x minus x1. Distribute. When you multiply these, it becomes positive, and the 2's cancel, so it's just positive 1. Oh, I left off the x.
Can you take her seriously?
They have to.
Bye, friend.
Bye. Like that. Do you use the y and the x as in the lowercase y and okay, so even though it's in intercept form, think that those are still just points, right? So this could still be your x1, y1, x2, y2. So this was a 6, right? I can't even read my writing. 6 minus 0 over 0 minus 5 would be 6 over negative 5. And then that's your slope. And then you already have b. So you just have to do y equals negative 6/5 x plus 6. But it wants it in standard form, which is the same thing as it wants it in general form, which is the same. Move this so it's positive 6/5. And then get rid of your fractions. So that's called general form or standard form. Those mean the same thing. But x and y same side, has to be x has to be positive, no fractions, no decimals.
Number 12.
Can you read it, Tony?
Yeah, it's right equation minus it's 3x plus 4y equals 7. And the points are negative 2/3.
Negative 2/4?
2/3.
Oh, I was like, that's weird. Negative 2/3.
And 7/8.
7/8. All right, so from this, I need is it say parallel too? Or is it A parallel and perpendicular? Yeah. It's parallel. So negative A over B is the shortcut, right? So negative 3/4. That's your slope for parallel. It is A parallel and B perpendicular. Yeah, okay. And then, so y minus y1 equals m times x minus a negative 2/3 is plus. And then for this one, for B, my slope is positive 4/3. So y minus 7/8 equals 4/3. X minus a negative 2/3 is again plus 2/3. So distribute. Here, the 3's would cancel, 2 goes into 4 twice, and I end up with negative 1/2. Add the 7/8. Times 4 and 4. So negative 4/8 plus 7/8 is plus 3/8. And then the other side, distribute. Distribute. And then add the 7/8. So this is going to multiply by 8 and 8. And then 9 and 9. So 64 over 72 plus 63 over 72. 127, yep. You're welcome. 2 is all about functions, okay? We're going to divide this into 2 parts. We'll get as far as we can on the second part, but we're going to talk about functions. We're going to get into domain. We're going to learn a bunch of things about a function. Function is huge on standardized tests. And it's like made so much more complicated than it needs to be. F of x, if you've ever seen it, that's function notation. F of x is the same thing as y. So we're still talking about lines and parabolas and all those things that could also be functions, okay? They're the same thing, it's just a different way of writing them. By definition, a function says that for each x value, there can only be one y value. which means an x cannot repeat with a different y. So if you are asked to find out if something is a function, they'll ask you in 3 ways. One is they'll give you a set of points. If it's a set of coordinate points, you're looking to see if the y, so if the x repeats and the y also repeats, like you have the same duplicate point, totally fine. But if the x repeats and it has a different y with it, then it fails your function test and it would not be a function. Then we're going to do that with a graph, and then we're going to do that with an equation, which we'll get to. Yep.
Can a y repeat with a different x?
So if a y repeats with a different x, it can be a function, but we're going to talk about one-to-one in a little bit. It would fail that one. But yes, the x can't repeat with a different y. So just look at all your x values. If they are different, it's a function. You don't even have to look at the y's. If one repeats and the y is also the same, it's still a function. But if the x repeats with a different y, it's going to not be a function. So that's the first thing you're look at. Number 1. Well, it just says determine if the set represents a function. So this is a yes or no answer, which means you better get it right on homework because you get 3 shots. Okay. All right. Number 1, look at all the x values. I've got 1, -2, 3. Do any of them repeat? No. So this is a yes, and I don't even have to look at the y's. Now go to number 2. Look at all the x values. Does the x repeat? Yes. Is the y different? Which means this is a no. So the x can't repeat with a different y. So you have a 1 with a 1, and then you have a 1 with a 2. You didn't even need the 1 with the 3. Already it's not a function. So 3 and 4 are just in like a T-chart format. If the arrows confuse you, you could rewrite these as points. So this would be 1, 2, this would be -2, 4, and this would be 3, 1. Same test. Look at the x's. Do the x's repeat? No, so this is a yes. Go to the second one. This would be 4, 1, -2, 1, and -2, 0. Does the x repeat this time with a different y? So it's a no. The second way you're going to test for a function is based on the vertical line test. So you're going to actually see a picture of a function, okay? Or a graph, sorry, not necessarily a function. And if you draw a vertical line through your graph and it intersects your graph at more than one point, it fails the vertical line test and it is not a function. So if a vertical line intersects your graph at more than one point, it is not a function. If you have the equation, then think about what kind of equations make something that would fail that vertical line test. It's something where the y is raised to an even power or the y is an absolute value. So if the y is raised to an even power, like it's y squared equals x, something like that, this is a parabola turned on its side. That would fail a vertical line test. And if it's y an absolute value, this is a v, which is the absolute value graph, turned on its side, and this would fail your vertical line test, okay? So these both back each other up. It just depends on which information you're getting. If it's a graph, you want to use the vertical line test. If it's an equation, you're looking to see if the y is raised to an even power or an absolute value, then it's a no. Yeah.
So if the x is raised, it's fine?
It's fine, because that's if the x is raised to the even power, it's a regular parabola, right? So if it's x squared, it's a parabola that points up, and that's going to pass a vertical line test. I could pass as many vertical lines through there. It's never going to hit that graph more than once. And think about your coordinate points. Here, let's say I had like, this is 1, and let's just say this is 2. This would be 1, 2, and down here would be 1, -2. It's an x that repeats with a different y. So again, it fails based on that. So all 3 of those tests overlap. You're just going to get given different information, and based on which information you're given, you want to use that method. All right, so now we're doing this algebraically, which means just look at your y, okay? If the y is raised to an even power, so it could be squared to the 4th, to the 6th, to the 10th, any of those, or an absolute value, then it is not a function. So is 1 a function? Is 2 a function?
No.
Is 3 a function?
No.
4? Yes. See how much easier this is than the crap you just went through on that test? The hard part of this is remembering when the yes-no process is much easier than a 17-step square and square root.
So the test should be easy, correct?
As long as you know what that means. All right, evaluating a function. So f of x is function notation. F of x is the same thing as y if you see it in equation format. If you see f with a value inside other than x, it's going to say evaluate f of 1, f of negative 2, f of whatever it is. And all that means is take the value that's inside the parentheses and plug it in for the x value and then simplify. So if it said f of 1 and I had f of x equals 3x plus 1, I'm going to take the 1 and plug it in the place of the x. And I'd get 3 times 1 plus 1, which is 4. So whatever's inside the parentheses next to your f goes in place of the x. Sometimes it's a value, and sometimes it's another variable. You just plug the variable in. Sometimes it's an expression. You just plug the expression in. And that would look like this, okay? So at the top, I give you two functions, f of x and g of x. Then look at your questions. Some of them are f of something and some of them are g of something. So if it's f, I grab the first one. If it's g, I grab the second one. So the f of 0 tells me grab the f of x, and everywhere there's an x, I put a 0. And I end up with 0 squared, which is 0, plus 3 times 0, which is 0, plus 1, and that's 1.
So you write f of 0 equals 1 or just 1?
So if, that's what I'm going to look at website. The answer could be written as just 1, or it could be f of 0 equals 1, like that. I'm going to look at website. For 2, I'm going to grab f again, and this time I'm going to replace the x with 1. So this would be 1 squared plus 3 times 1 plus 1, 1 plus 3 plus 1, or 4 plus 1, which is 5. So f of 1 equals 5. Go to 3. 3 is f of negative 1. So again, this time I'm grabbing the f again, and then I'm plugging in the negative 1. So negative 1 goes in parentheses, okay? So be careful there. Because remember, negative 1 squared without the parentheses would be completely different, right? Negative 1 without the parentheses, you would square the 1 and then take the negative. If it's like that, it goes in with the negative. Yeah, so this becomes 1 minus 3 plus 1, negative 2 plus 1, which is negative 1. On WebAssign, it gives you just the box. So it'll say like f of negative 1, and then it gives you this box. So you're just writing negative 1. You don't have to write f of negative 1 equals negative 1. 4 changes to g of x. So I'm going to use the second one. So g of x is negative x squared plus 4x plus 1. That negative goes on the front, then 2 gets squared plus 4 times 2 plus 1. So be careful there because you're going to square first and then take the negative. It's not in the parentheses. So this becomes negative 4 plus 8 plus 1, or 4 plus 1, which is 5. And again, it just leaves you the space to put the 5. Now 5 says g of t. So in place of the x goes the t. It would be negative t squared plus 4 times t plus 1. We are not solving these. These are not equals 0. So you don't have to like use the quadratic formula on that. That's as far as you can go. So even if it was factorable, I would leave it like that. And 6 is x plus 2. So I get negative, open the parentheses, x plus 2 squared plus 4, x plus 2 plus 1. Now I have to expand and FOIL and distribute. So the negative is still on the front. x plus 2 times x plus 2, you can use the shortcut because it's a special product, would be x squared, square the first, square the last, double the product, and I get positive 4x. Distribute the 4 here. Now distribute the negative. I just combine these. And then combine your like terms. So negative x squared, a negative 4x and a positive 4x cancel out. Negative 4, positive 9 is positive 5. All right, now we've got h of actually. All right, so for one, you're plugging in the 2, you should get negative 2. 2, you're plugging negative 2, you should also get negative 2. And then for 3, you're plugging in x minus 1. You've got to expand and FOIL or use the shortcut. Distribute the negative 3. Make sure that negative goes to all 3 terms. And you get negative 3x squared plus 6x plus 7. Raise your hand if you got them all right. Good. Questions? All right, so now we're going to do something called piecewise functions, okay? A piecewise function just means that your different h of x is split into parts, or f of x, whatever it is, split into parts based on the values you're plugging in. So this is what a piecewise function looks like, okay? And what it's telling you is that f of x could equal either of those two things depending on what the value you're plugging in. So for the values that are for x is less than 0, so we're saying anything that's less than 0, we're going to use this x squared minus 1. And then if the value I'm plugging in is greater than or equal to 0, I'm going to use x minus 1. So first, you look at what's inside the parentheses and figure out if it's less than 0 or greater than or equal to 0. And then based on that, you grab whichever one you're supposed to use. So if I look at A, I've got negative 1. Is negative 1 less than 0 or greater than or equal to 0? It's less than 0, so I'm going to use the top equation. So I'd get x squared minus 1. I'd replace x squared with negative 1. Negative 1 squared would be 1 minus 1, and this is 0. So it is not both. Like I have seen people plug it into both and write separated with a comma. That's wrong. There's only going to be one or the other. You got to figure out which one. Go to B. Now it's f of 0. Is 0 less than 0 or greater than or equal to 0? Greater than or equal, which means I'm using the second one, x minus 1. So I get 0 minus 1, which is negative 1. And the last one is f of 1. So is 1 less than 0 or greater than or equal to 0? Greater than or equal, so I use x minus 1, and I do 1 minus 1, which is 0. Questions on those? All right, these instructions say find where f of x equals 0. And hint, these are also x-intercepts. So remember we said f of x is the same thing as y, right? If y is 0, it's an x-intercept. That's what that means. But really all this is saying is take my f of x and replace it with 0. So every time I see an f of x, I'm going to replace that whole thing with 0. And then I want to solve for x. So if I had 0 equals negative 2x plus 10, what do I do to get x by itself? You can subtract the 10. And then divide by negative 2. X would equal 5. Yep.
So what does that also x-intercept mean?
Because if f of x is 0, you're saying y is 0. So if I was to graph this on my, like if that's a line, right? So if I use y equals mx plus b, if I started at positive 10, and I went down 2 into the right one and down to the right one, and I drew my line, the point where it crosses the y-intercept should be the same as what I have there. So this is the same, not the y-axis, sorry, the x-axis. This is the same as saying the x-intercepts. So if I were to graph this, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up here, and then I went down 2 into the right one and down 2 into the right one, and I did this accurately, I would cross through my x-axis at 5 because it's where y is 0. And to find an x-intercept, we make y 0. So they just double as two things. One is an answer for this equals 0, but also on a graph, you would see it cross through the x-axis at that point. Dustin.
Wait, so if we take slope-intercept form and just plug in 0 for y, we can find the x-intercept?
Yep. And vice versa. Plug 0 in for x and you find the y-intercept. Yeah.
So if it says f of x equals 0, that's when you set the whole equation.
The whole thing. So it's not f of 0, right? If it's inside the parentheses, I'm just replacing the x, but the whole f of x is 0. So that whole thing gets replaced with 0. So like in 2, it would be 0 equals x squared minus 5x plus 6. How do I solve that?
Take out an
Factor. I said it's like somebody saying the F word. You have to factor. Okay? Factors of positive 6 that sum to negative 5. That's the trickiest one. Negative 3, negative 2, right? Because the 6 has to be positive. Split and solve, and I get 3 and 2. Go to 3. 0 equals x squared minus 16. Sorry. All right. 0 equals x squared minus 16. How do I solve it? You can add 16. And then? Don't forget to do what, though? Good. You could also have factored it in the difference 2 squares, got the same answer. Okay. How do I factor 4? Good. 81x. X squared minus 81. Am I done factoring? Nope. Difference of 2 squares. Set them each equal to 0. And 5. What would you do first here? Multiply by 3. I get 0 equals 5 minus 6x. Then either subtract the 5 or add the 6. You do either one, right? Negative 6x. And divide by negative 6. X equals 5/6. So I'm going to teach you something that just saves you time. If this confuses you again, don't use it. Go back to your basic steps. But if you look up here at this equation before we multiplied by 3, the left side is 0. What is always going to happen when I multiply by the denominator? It's always going to go away because it's always going to be 0. So if I have this set equal to 0, then I literally can ignore the bottom and just set my numerator equal to 0. Even if there was a variable there, we're going to learn about how to restrict that, but even if there was a variable there, it's not going to impact my x-intercepts because it's only the top, because it's always going to cancel out, okay? So when you have a fraction, you can literally just set your numerator equal to 0 to find your x-intercepts or to find where f of x equals 0. It saves you one step here, but sometimes it gets more complicated. All right, example 6 says find where f of x equals g of x. So each of these have both an f of x and a g of x. What do you think you're going to do? Set them equal to each other. So x squared plus 1 would equal 3x minus x squared. Now what? I can move the x squared to be over here, right? So the terms are on the same side. I get 2x squared plus 1 equals 3x. and move the 3x. As soon as you see that you've got an x squared and an x, you know you're going to have to factor. Now I can multiply first times last or do trial and error, right? First times last is 2. Factors of 2 that sum to -3. Good. Plug those in. 2x squared minus 1x minus 2x plus 1. Factor by grouping. Take out an x. 2x minus 1. Take out a -1. 2x minus 1. And I get 2x minus 1 times x minus 1. Split and solve. And I get a positive 1/2 and a positive 1. And you just enter, I was checking to see what sign does. If it makes you put them in order. It doesn't. It just says separate it by a comma. So you just got to list them. Same directions for 2. So I'm going to set these equal to each other. X squared minus 1 equals negative x squared plus x plus 2. I'm going to add the x squared. 2x squared minus 1 equals x plus 2. Subtract the x and the 2. 2x squared minus x minus 3 equals 0. First and last. Factors of -6 that sum to -1. Good. And then factor by grouping. And I end up with -1 and 3/2. Questions on anything we talked about so far today? Sophia? All right, so this is the second part of 2-2, and the focus is on domain. It's still functions, but the focus is on domain. So the domain of a function is all the values of x that can be plugged into that function. If you are looking at a graph, you would look from left to right. So if I had a graph that had, if it was just like, let's say, a line with arrows on both sides, there is no stop to the values going left and there's no stop to the values going right. The domain on this would be -infinity to positive infinity. But if I had a line that started with a solid dot, like I'm not getting an arrow on that side, and then it points to the right, let's say that this is, I should have put tick marks on this, but let's say that this is 1, 2, 3. Let's say that x value is -3, then this domain is -3 to positive infinity. The solid dot gets a bracket because that solid dot is part of my graph. And the arrow says go on to infinity in this direction. So as we read domain from a graph, it would be left to right. The smallest point to the left, pointing towards the right. Yeah.
Would there ever be like a case that the -3 has a parentheses instead of a bracket?
Yep, it would be an open dot. We'll talk about that next week. So today we're going to focus on the equations and how to find domain from the equation, and same for tomorrow. And then we'll switch over to graphs like next week. Yep.
What if it's a negative slope?
What if what? It won't matter. If the arrow is pointing to the right, it's still pointing to the right. So you said negative slope, right? Yeah. Okay, and for now, we're going to focus on how to find domain from an equation. And we've done a little bit of this when we talked about restrictions on fractions. That's kind of part of this. But now we're talking specifically on any kind of equation. So if your equation does not have a variable in the bottom or a variable under the square root, the answer is all real numbers. So the slope of a line, or an equation of a line, like a y equals 2x plus 1, all real numbers. There's no restriction there. There is no value of x I could plug into that equation where my answer would be undefined. I could get a squared, x squared, and there would be no restriction on that because, again, there's no value I can't plug into x. But as soon as I get a variable in the denominator, which is the first kind of restriction, like y equals 1 over x, if that denominator is 0, what happens to my equation? It's undefined. 1 divided by 0 is undefined, okay? So if there's a variable in the denominator, then we set the denominator not equal to 0. Whatever's down there, if it's just an x, x cannot equal 0. If it was x plus 1 cannot equal 0. Whatever's in the bottom, you would set not equal to 0. The other kind of restriction is underneath the square root. So if I had the square root of x, what values can I not square root? You can square root positives, you can't square root negatives, right? Well, you can still square root them. They don't have to be whole numbers, but you can square root them. So we're looking for something that would literally give you an imaginary number, because we're graphing these, we're not doing imaginary numbers. So these would have to be anything 0 or bigger than 0. Does that make sense? So when there's a variable under a square root, we set whatever's underneath the square root greater than or equal to 0, and that's how we figure out what values we can use. So in this case, it would be x has to be greater than or equal to 0. The third is the overlap of the two. There's a variable in the denominator underneath the square root. Now, it still can't be negative because I can't square root a negative, but it can no longer be 0 because it's in the denominator. So now for that one, we set whatever's underneath the square root greater than 0. It's no longer greater than or equal to. So those three things are restricted. Anything else is all real numbers. So 1 is based on just point value. What did we say? Which coordinate is your domain, x or y? So if I have coordinate points, then my domain is literally a list of all the x's. So it is 3, 4, 5, and 8. Just listing the x values. The rest of them are equation based. So we are looking to see if there's a variable in the denominator, a variable under a square root, or a variable under a square root in the denominator. Are any of those cases happening in 2? So my answer here is all real numbers. And in interval notation, it would be negative infinity to positive infinity. There is no restriction.
If it was a negative slope, would they switch?
No, it will always, so it's always smallest to largest. So negative infinity to positive infinity will always go in that order. Yep. How about 3? Is there a restriction on 3? Nope. All real numbers again, negative infinity to positive infinity.
Do you write on the website just all real numbers?
I think it's, let me open up that one. I think it's interval notation, but let me look at it. How about 4? Is there a restriction on 4? Variable in the denominator, variable under square root, or the combination. X squared, I can plug any, you can square any number, right? So this is negative infinity to positive infinity. How about 5?
No.
Still none. All real numbers. How about 6? Yes. Now there's a variable in the denominator. Whatever's in the denominator cannot equal 0. So in interval notation, this would be negative infinity to 0 with a parentheses on the 0 because you can't include it. Union 0 to positive infinity. That's how we write not equals in interval notation. On WebAssign, it actually says words. All real numbers except. So you can write all real numbers except 0. And it's multiple choice. So the words are there. Yep. This would be for tomorrow's homework, though, not tonight. Tomorrow's. Yep.